Okay, so suppose I give you 2 points on the plane, and I want you to find the exact distance between them. How would you do it? Well, there's actually a thing called the distance formula, and I hope you will not memorize it, because you shouldn't memorize it. Let's think through exactly how one could figure out what that formula would be. So let's suppose I give you 2 points. Maybe one is way over here. Now, I won't know the coordinates of the point just for this example, because I want to actually generate this formula for you. So suppose that this x value is just x1, and the y value would be y1. Okay? Then I have another point. Let's say this point's way over here. And that value, the x value, I go over x2, but I go up to y2. So I want you to understand what this means. This is just a point. The coordinates of the point are x1, y1. Don't get nervous by that. It's just some number. It could be like, maybe 3, 2. I just don't know what those values are right now, and I want to use general values to actually create this formula for you. This second point has some different coordinates. So maybe this is like 10, 8. So I'm calling x2 that value, and I go up y2. Okay, now I want to find the distance between them, so what I want to do is connect them with a straight line. And so the question is, how long is this line? Well, you can memorize, like I said, the formula for this, or you can just think about it for a second and realize that that's actually the hypotenuse of a right triangle. And let me draw in the right triangle so you can actually see it. In fact, let me draw it in my right triangle color, which I just decided is going to be green. You see how you can do this on the fly? Live math, ladies and gentlemen, live math. So if I just draw these 2 lines, one horizontal and one vertical, you see I have a nice right triangle here. Well, this is great, because I can use now the Pythagorean theorem to find the hypotenuse if I know the lengths of each of these sides. But I do, because this length is going to be what? Well, it's the distance basically between here and here. So that's going to be x2, and then I subtract off that distance, which is x1. So this is actually x2 minus x1. And this distance right here, well, that's just going to be all of y2, but then I subtract off y1. So this is actually y2 minus y1. So what does the Pythagorean theorem say? Well, this is the distance I want. Let me call this dist. Like I got dist. Well, it's in the story. Did I still use the expression dist, for getting dumped? Maybe not. It was when I was a kid. Okay, I'll tell you about this some other time. Anyway, if I call this distance between these 2 points dist, then what do I know? I know from the Pythagorean theorem that this length squared plus that length squared will equal this squared. So what that would mean is that dist, the hypotenuse, squared equals, well, this squared, which is x2 minus x1 squared, which, by the way, doesn't equal x2 squared minus x1 squared. That is the #1 classic mistake. Bing! #1. Squaring mistake. Remember to FOIL. Okay? Plus that length squared, which is y2 minus y1 squared. So if I now want to solve for distance alone, I have to take square roots. Now, technically, I have to take plus or minus the square root. But since this is a distance, we know that there are no negative distances, so it has to be the positive root. So now, today, I can actually just take the 1 square root and say that the distance is equal to just the regular square root of x2 minus x1 squared plus y2 minus y1 squared. So in fact, that is the formula for distance, or sometimes called the distance formula. So the distance between 2 points is given by this. You subtract the x values and square it, subtract the y values, square it, add those 2 numbers together, take the square root. That's the distance. But I hope you won't memorize that. I hope instead you just think of this picture. That's what I always do. Let's try an example. So suppose I want to find the distance between the points 6, 4 and minus 8, 11. Okay, so what's the distance? Well, what I do is you can think about it graphically and set up the triangle, and we'd see that the distance would equal the square root, and I take the differences of the x's. Now, the important thing here is to always subtract sort of this x from, let's say, that x. So that would be, whoops, I'm writing the wrong thing. 6 minus negative 8 squared plus 4 minus 11 squared. Notice I'm subtracting these points from these points. So that equals the square root. Well, 6 minus 8 is 6 plus 8, and 6 plus 8 is around 14, so I have 14 squared, plus, and then I have 4 minus 11, and so 4 minus 11 is what? Is that minus 7 squared? So what is this? Well, the square root of 14 is 196, plus the square root, and the square of minus 7 is just 49. And so what I see here is the square root of 245. And you can use a calculator, for example, to see that this equals, I worked this out in advance actually, 15.65 stuff. Goes on. So this is the actual answer, and this gives you a sense of what it is. It's around 15.65. But the actual distance between these 2 points, if you put down a measuring tape, would be the square root of 245, or 15.6 something. Okay, so that's how you find distances. What if I give you 2 points, and I want you to find the point that's right in between them? Let's think about that for a second. So now we can find the distance, but suppose I give you a point right here. Let me call this point, again, x1, and I'm going to call this y1. And I give you a point way over here. I call this x2, and its y value I'll call y2. And okay, well, you can draw the line that connects them. This is the shortest distance. We just figured out how to find that distance if we wanted to. But suppose instead of finding that distance, I want to find the point right in between. So that point right in between would look just like this. It'd be right there. How would you find that point? Well, let's think about that for a second. What would I have to do? Well, it would sort of be in the middle of this, and it would be in the middle of this. So how would I find the middle of this? Well, the middle of this, in some sense, is like the average of these two numbers. It's the thing right in the middle. So how do you find the average? What I would do is I would just add these two numbers up and divide by 2. So x1 plus x2, and I divide the whole thing by 2. That's the middle, the thing that's right in the middle here. And where would this point be? Well, it would be in the middle of these two things, which would be taking the average, y2 plus y1, and divide by 2. That's this point right here. So in fact, the coordinates of the midpoint between 2 points are going to be x1 plus x2 over 2, comma, and the y is going to be y2 plus y1 over 2. So in fact, this is how you find the coordinates of the midpoint between 2 points. And again, I don't think you should memorize it. Just remember that you sort of want to find the average between the x's and then the average between the y's. And you find like that. Let's do a quick example together. Let's find the midpoint. So find the midpoint between the points 1, minus 1, and the point 5, 5. So if I want to find the midpoint, what I have to do is average the x's and then average the y's. So the midpoint would be, well, I'd average the x's. So I add 1 plus 5 and divide it by 2. And then I average the y's, minus 1 plus 5 divided by 2. And that would equal 6 over 2 and 4 over 2, which would be the point 3 over 2. I'm sorry, not 3 over 2, 3 comma 2. 3 comma 2. That should be the midpoint. Let's just sort of really fast just sort of graph this and see if that looks okay. So I'm going to put that over there so you can see there's the midpoint. Let's see if this makes any sense at all. So the first point over there was 1 minus 1. So I go 1 unit over, and then minus 1, so that's 1 unit down. So there's the point 1 minus 1. The other point is 5, 5. 1, 2, 3, 4, 5. This is, of course, very rough, as you can see. 1, 2, 3, 4, 5. I'm literally eyeballing this. I'm not even trying to be accurate, just to get a sense if this answer makes sense or not. Sometimes it's worth thinking about if an answer even just makes sense. This is 5, 5. If I connect them, these 2 points with a straight line, that line would look like this. There's the line. And where's the midpoint? The midpoint looks like it's sort of around here. And let's see, does that midpoint look like it's around the point 3, 2? Well, in fact, look at this picture. This is absolutely amazing. I swear this is live. Here is 3. I don't know if you can see that little mark for 3. But look at it. It's exactly over 3. And here is 2. It is exactly on 2. So even on this little sketchy, lousy little drawing, you can see that this answer is certainly reasonable. And of course, from the mathematics, we know it's absolutely correct. So pretty easy to find midpoints. We just average the x's, add them up, divide by 2, average the y's, add them up, divide by 2. That gives you the midpoint. To find the distance formula, I just use the Pythagorean theorem to create a right triangle and find the length of the hypotenuse.